So let's do a third kind of sort that we have seen, which is called insertion sort. Right? This runs in again time order n square, but it is a little more involved. Right? The total number of steps is probably a little lesser, but the runtime could be still as much as order n square. Right? So once again, we are given an array a1 to n, and the swap algorithm which is there that we will need. So I'm just keeping that here as well. And now let's go to insertion sort. So what do we do here? So go back to the slides and check. We have already worked through many examples for insertion sort, right? And just revise that before you begin this video in case you don't remember. So in insertion sort, what we're doing is we will start from the first element, okay? And then we will sort of look back and see where we have to place the element, right? We are looking back to see where we have to place the element depending on the order that we need, which is the ascending order, right? So for instance, A is the array, A1, just by looking at the first element, there is nothing to do. So the whole process starts from the second element. So for I equal to 2 to A dot n, right? What are we really checking here? We are essentially assuming that everything from index 1 to index I minus 1 is already sorted. And in fact, the way we do it, this will always be the case, right? Because this is inductive swapping, correct? So assuming that everything from 1 to I minus 1 is already sorted, okay, we want to find the index at which, correct index at which we need to place the element at I, so that 1 to I will be sorted. Okay, so how do we find that out? We find that out by comparing AI with every AJ where J is less than I, where J is between 1 to I minus 1. Is that right? Okay, so again, let's check. So then the algorithm for J equal to, what are we now comparing? I minus 1 to 1. You understand this? This loop is now going downwards. First loop was going upwards. I equal to 2 to A. This loop is going downwards. J equal to I minus 1 to 1, I minus 1, I minus 2, I minus 3, up to 1. Okay, is that okay? So that is what we want to do. And now we want to find the correct index, right? We want to find the correct index for placing A of I. So once again, we will do the same thing that we did in one of the algorithms before. So we'll declare an index variable and initialize that to I. So let index be I. Okay. The index is I because we are starting from the ith position and we want to place the value at the ith position at some other place. So index is I. Now for j between I minus 1 to 1 going down, what are you supposed to compare aj with ai? And when are you supposed to place it back? So basically you're supposed to go on searching. As long as the element is greater, you don't do anything. Understand? In other words, it's not even if. Oh, sorry, yeah, it is it. So if aj is greater than or equal to ai, I don't do anything. I just say index equal to index minus 1. Okay, because I am not interested in placing it at the position j. I want to look further down, further down, further down. Finally, at some j, aj will be less than ai. That is where I need to swap. Is that correct? Okay, so index x minus 1. Else, what do we do here? Well, we don't do anything. The thing is, just think about it. Just run through the example and see. What do we do? The moment AI becomes less than AJ, we have to stop. We don't continue searching for elements further because the smaller array before that is already sorted. It is already sorted. So we are not looking for elements before that. So else break for loop. That's what we are supposed to do. Okay. The moment AJ becomes less than AI, break for loop. Right? That's what we're supposed to do. And then we come out of this. Okay. And now where do we place this element? So now the element AI is supposed to be placed at the place given by index. At the place given by index. But everything between index and I minus 1 is supposed to be also pushed ahead. Okay. Also pushed ahead. Which means we need to do two things. So what is that? Again, so now swapping elements. So let's take a temporary variable t equal to ai. Is that okay? Now for let's say j equal to from where to where? From index to I minus 1. This is increasing now. Index to I minus 1. We push the elements forward. So a j plus 1 equal to aj. Right? So a index goes to a index plus 1, a index plus 1 goes to a index plus 2, a index plus 2 goes to a index plus 3, forward, 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 forward. Is that clear? Now, is there a problem here? There is a problem once again. Because when you put a index to a index plus 1, the value at a index plus 1 is lost. You are not supposed to lose it. Okay, the only value you can afford to lose is AI because that is already stored in the temporary variable. Okay, so how do you sort that out? Instead of increasing, you decrease index I minus 1 to index. Why is now not a problem? Because the first step itself, check aj plus 1 equal to aj. So ai will take the value ai minus 1. Then the value ai is lost, but it is okay because it is already stored in the box T. But instead, if you start from index and go ahead, then you are losing values that are ahead. They are not stored anywhere. Only AI is stored in this box. So you can only shift the values to AI and then do it inductively. Okay. So that is what this is. Just run through the example and look at the examples that we have seen in the lecture. This is exactly what we are doing. Exactly what we are doing. Okay. Just convince yourself of that. So we do this and this end for what else remains? Well, now we have to place this element back at the index location. So a index equal to. Is that okay? So that's exactly what we do here. A index equal to B. All right. So that is the insertion sort. Now you can also do this via swapping. Okay. You can do this very, very easily, especially this part. This part. You can do this by using the swap function that we have seen before. Okay, so that I am giving to you as an exercise. That's a very easy thing. So that is the exercise. Right? Insertion sort using. So in bracket we don't write it. Using swap. Well, let's say rewrite. Rewrite. It's the same thing, they're equivalent, but you can rewrite them. So hint is this is the part which will change. This is the part which will change in terms of the swap operator. Is that okay? So that with that I'll stop this part.